In this video, we're focusing on some special situations that are going to come about when we're solving equations. And two things to remain focused on is what will make the equation true? That's the essential question that overarches everything we're doing when solving equations. And also, is there a way possible to look at this equation and see that it will be balanced? Is there a possibility that one side of the equation possibly weighs more than the other side? So if we consider the left side and the right side of this equation, can you look at it and ask and answer the question, which side weighs more? Well, both sides have a 2x on them. So what if we were to get rid of the 2x? Remember, think of the left-hand side and the right-hand side as if they're on a scale. So what if we took the 2x away from both sides? It appears that the right-hand side is going to weigh more. It's going to weigh 8 more because this is -5 and this is +3. So what does that mean in terms of finding a solution? Well, let's apply the properties of algebra and see how all of this plays out. So first of all, let's keep going with our strategy that we've already been using, which is to get all our variables, in this case the x's on the left, and get our constants on the right. So if we do this, we end up with taking 2x away from both sides, and that's of course by the subtraction property of equality. So if we take 2x away from both sides, we end up with simply -5 = 3, which is what we saw when I just covered it up with my fingers. Now, remember, this is the equal sign. The equal sign by definition says these two sides are equal to each other. They weigh the same. But do they? Is this a true statement? True? No, it's not true. Now I'm going to add one thing back into this equation. So what if we didn't just cancel out that 2x? And just to make this look a little neater, I'm going to cover up where I had that true right there, not true. So what if we said 2x minus 2x is 0x? And what if we use the addition property of equality and we added the 5 to both sides? Look at this and let's ask this question finally. All right, so now we've got 0 times x equals 8. Is there any number that we can multiply to 0 that will ever make this true? No. Because no matter what we plug in for x, it's going to get multiplied to 0, and no matter what, it's going to be equal to 0, and 0 is never going to be equal to 8. So what we're seeing here is that this left-hand side is never going to weigh the same as the right-hand side. There is no way to make this equation balanced. Therefore, there is no solution to this equation. So you can write no solution, or you can use this little symbol which represents no solution. But we are going to see equations where the left-hand side and the right-hand side are never going to be equal to each other no matter what. And this one we were able to see pretty quickly right up front. Because as soon as we take away those two x's, we see that the left-hand side is never going to be the same as the right-hand side. Let's check another problem. So here we've got 6x plus 2 times 2x minus 10 equals 7x minus 5 minus 3x. Now, this equation, we got to do some work first. So, keeping my equal signs lined up, we are going to follow order of operations on the left, and we are going to follow order of operations on the right, and then we're going to combine like terms. We always first want to take an opportunity to use order of operations to simplify the left, simplify the right, before we even start solving the equation. So let's do that. So 6x plus 2 times 2x minus 10. Now there's nothing to do inside of the parentheses, but we can use the distributive property in order to excuse me, multiply by 2. So we end up with 6x plus 4x minus 20. That's what we get when we distribute the 2 through. We're following order of operations here. We're going to keep going, and we are going to combine the like terms here on the left-hand side. 6x plus 4x is 10x minus 20. So we have tidied up that left-hand side as much as possible. We need to do the same thing on the right. Now, I've chosen this problem because we have the situation where we have a minus sign that is directly in front of parentheses. And when we have a minus sign that directly precedes parentheses, it does indicate that we need to use the distributive property, and we will be distributing a -1. So we're following order of operations. We're simplifying the left-hand side. We're simplifying the right-hand side. So 7x stays. -1 times 5 is -5. -1 times -3 is plus 3x. So we've used the distributive property. Now we are going to combine like terms. The like terms on the right-hand side are the 7x and the 3x. So we end up with 10x minus 5. Now that we've got the left-hand side simplified, the right-hand side simplified, let's take a look here. Don't just march ahead without considering what's actually given in this situation. The situation is like the previous problem in that if we take away that 10x from both sides, which we can totally do that, that's just using the subtraction property of equality. So if we subtract that 10x from both sides, we end up with a statement that says -20 is equal to -5. Now, does that make sense? Is there anything that I could ever plug in for x that's ever going to make that make sense? It's not. So what we've got here is an unbalanced equation. There's nothing that we can plug in that's ever going to make it true. In case you don't believe me and you just charge forward, what would we get if we subtracted 10x from both sides? We would get 0x minus 20 equals -5. And then from here, plus 20 plus 20, 0x equals 15. 0 times what equals 15? Anything? Nothing. There is no solution to this equation. Why? Because the left-hand side is never going to balance with the right-hand side.